Alright guys, today we're going to be talking about proportions and conversions part 1. And so before I discuss how to solve these problems, I do want to talk a little bit about why proportions matter and why converting rates matter. Okay, and that's really that in many aspects of life, it's too much to compare reality. It costs too much. But if you know a proportion exists, you can find the appropriate information. So let's say you're an engineer and you want to build a home. You know you have an idea of what it's going to cost. You need to know how much it's going to cost to build the home. You want to build an effective home. And so what you may do is you may model that. You may build a model to represent reality. And then what you can do is you can scale, the word being important word, scale the model to fit reality, to fit the actual size of the building. So it allows efficiency by allowing modeling. You yourself can do this, right? You can sit there and you can ask yourself, well, it usually takes me, let's say, 30 minutes to do 5 Khan Academy assignments. And then you say, well, I need to get through 15. You could make a proportion to figure that out. So really helpful in terms of breaking things down and looking at the world in a smaller example to scale it up to a bigger. And that's one of the main, not the only, but one of the best ways of using proportions in the real world. Okay, so what are proportions? Well, let's look at this problem here. It says, the first thing we really want to talk about is something called cross multiplication or cross products. And so the question here is to decide whether 4/5 and 16/20 are equivalent. So what we can say here is 4/5 is it equivalent to 16/20. And there's a couple ways of doing this. What the notes are asking you to do is to cross multiply. Okay, so if I cross multiply, I get 4 times 20 equals 5 times 16. And I want to see if that's true. So if I multiply 4 by 20, I'm going to get 80. And if I multiply 5 by 16, I'm going to also get 80. And so this is actually true. But let's look at this a little bit more in depth. Why is that true? So let's say instead of numbers, last time we talked about letters. So what we want to see is it true that if I cross multiply A times D by B times C, is it the same thing as A over B equals C over D? So notice when we cross multiply, we get AD equals BC. So can I use the skills that we've developed from before to take AD equals BC and say it actually takes me back here? So in other words, can I get A over B on the left? Well, notice that we have B on the right. So if I wanted to do that, I could divide by B, and I could say A over D divided by B equals C. And then I can take this new equation that I have. Let me rewrite it here. I'm just rewriting exactly what I just wrote above. And notice that if I want C over D on the right. So if I have D here, could I not divide by D on both sides? The D's would cancel out, and I'll have A over B equals C over D. And we can see that it is the same thing. We just now did something called a proof. We showed that it really is the same thing. What cross multiplication really is you're really just getting rid of the denominators. So what you're really doing is if you multiply both sides by BD, okay, multiply both sides by the denominator, what you're going to see, and this is okay because what I did to one side I did to the other, is that when we do this, B and B divide out and we get A over D, and here D and D divide out and we get B over C. And that's another reason why cross multiplication is a legit move. So what have I really done? I've taken something we've learned before, right? We know we can add, subtract, multiply, and divide as long as what we do to one side equation we do to the other. We see that that's what's occurring here, and we did that, and we proved to ourselves that A over D equals B over C when we cross multiply. Okay, so two different proofs showing the same exact thing, and this is also showing why literal equations are useful, the topic we talked about last time, right? It allows us to develop new techniques towards solving proportions. So, in any case, I know you guys like that. Doing the cross multiply, also sometimes called the butterfly, right? That helps you out. Let's look at the next one. Let's do the same thing on the next one. So we have 25 over 36. We're going to see if that is the same thing as 15 over 20. Now, one thing you may want to do here, that may make your life a little easier, is these numbers are going to get pretty big when I cross multiply. So maybe I wanted to reduce, and I notice that 15 over 20, I can divide that, and 15 over 20 is just 15 divided by 5 is 3, and 20 divided by 5 is 4. So why don't I look at 25 over 36 equals to 3 over 4? Okay, let's examine that. Okay, so I wrote it down here because it was getting a little cluttered. Okay, so we can cross multiply. Now, when we cross multiply, we get 25 times 4 equals 36 times 3, right? We're taking the top left, multiplying by the bottom right, and taking the bottom left and multiplying by the top right. And we get this. And here's something that I think is a pretty interesting idea to come across. I know that you all are used to just typing things into the calculator, but even if I want to go about doing this, I can actually do this pretty quickly without having to fully solve the problem. Because 25 times 4 quarters makes $1, right? So that's easily 100. There's no way if I multiply 36 by 3, just think about 6 times 3 is 18, right? There's no way that the product, when you multiply 36 times 3, we call it the result, the product can never be 100. So you don't have to actually solve it all the way. You can just look at it and you can see that those would not be equivalent, okay? So we can say for the first one, we can say that that is true, and for the second one, that would not. Let's move on. Okay, so the next question is saying solve the proportion. So now we want to find the case that is true. And so here if I cross multiply, I'm going to rewrite this as 6 times 5 equals 3 times z. Now I'm going to do something very interesting here that you piggybacks off of the idea from the last one. I'm actually not going to write out what 6 times 5 is. I don't need to do that because the next step we usually say is cross multiply and divide, right? We've seen this scenario a lot. If I want to get z by itself, we're going to divide. So why wouldn't I multiply 6 times 5? Because it's a lot easier to put 3 into 6 and get 2 and just do 2 times 5, which is 10, and z is 10. Okay? It's a lot easier to do that than it is to get 6 times 5, which is 30, and divide by 3. Well, maybe not in this case, because 30 divided by 3 is easy to do. But imagine if you got really big, ugly numbers. Imagine if you had to multiply two numbers that were really, really, really hard to multiply by. Then it would be a problem. It would be a little bit more difficult. So that's why we approach it this way. I also want you to see something here that's also pretty interesting. If I plug in 10, we have 6 over 10 equals 3 over 5. What a proportion really is saying, it's a ratio of values. And so if we say that we have some value behind 3 and 5 that we don't know, we'll call it x. What we're really saying is that if we can write 3 over 5 as 3 times 1 over 5 times 1, we can write 6 as 3 times 2 over 5 times 2. What I'm trying to say is what a proportion is it's always 3 times something is equivalent to 5 times something, right? It's in that scale. So anything, so like we could do another scale if we wanted to. We could say 9 over 15. You could be asking yourself, well, Mr. Anderson, where did those numbers come from? And I would tell you 3 times 3 is 9 and 5 times 3 is 15, right? It's just another version of this. And we know that it's true because this will cancel out, this will cancel out, this will cancel out, right? And this will always leave you with 3 over 5, 3 over 5, 3 over 5, okay? What this is also saying is that another way to approach this, let me rewrite the question here. 6 over z equals 3 over 5. You can approach it this way. You can say 3 times what is 6? 3 times 2 is 6. So 5 times what is z? 5 times 2 is z. And that gives me 10. So what I'm trying to show is all these ideas that we've talked about are useful towards solving these problems. You find the one that is most effective for you and use that to get to the correct answer. All right, let's move on to B. So in B, again, we can cross multiply. And we'll get 8 times m equals 5 times 6. Is it a problem now that the variable is on one side versus the other? Absolutely not. The approach is still the same. So I'm going to divide by 8. Notice again, I did not multiply out 5 times 6. I'm not concerned with that, because I can look at 5 times 6 over 8 and easily see that 6 and 8 are both divisible by 2, which leaves me with 4 and 3. And look at this and say, can I put 4 into 5 or into 3? Nope, I'm done. 5 times 3 is 15 over 4, and there's my answer. Cool, let's move on. All right, so we're in another interesting situation here. All right, so same idea, we can always cross multiply. So 3 times x minus 7 equals 4 times x plus 3. So we just cross multiply. All right, so I'm looking for easy ways to solve this. I can't. I'm going to revert back to what we learned about having to solve these problems. So after you've checked to see if you can combine like terms inside the parentheses, you're going to distribute. So we have 3x minus 21 equals 4x plus 12. And I hope that you're seeing that I'm doing 3 times negative 7 to get negative 21. 4 times 3, that's where the 12 is coming from. Okay, so what do I do from here? Well, what I'm going to do now is I'm going to combine like terms. So what I'm going to do is I'm going to subtract 3x from both sides to put my x's together. Watch the sign. So notice when I took this down, it was negative 21. I brought down negative 21. And then to finish it off, subtract 12 from both sides. And x is negative 33. Okay? Now, interest of time, I'm not going to do this, but you could always check, right, by substituting it x back into the original problem and seeing if it's true. Let's do the next one. So, let me rewrite this. This is d minus 1 over d minus 4 equals 4. I'm actually going to rewrite 4 as 4 over 1. So again, I'm going to just cross multiply. So d minus 1 times 1 is d minus 1. And 4 times d minus 4 is 4 times d minus 4. And then we'll do what we did before. We'll distribute. D minus 1 equals 4d minus 16. And so let's solve this. So how do we go about solving this? We're going to subtract d from both sides. And then what are we going to do? Then we're going to, sorry, I'm running out of colors here, add 16 to both sides. Okay, so when I do that, I get 15 equals 3d. I thought I was about to get something without an ugly fraction, but nope. Divide both sides by 3, and d is 5. And there you have it. Okay. One more situation. So this is a real life example. So they are saying that 8 ounces of a can of oranges contains 97 milligrams of vitamin C. So 8 ounces contains 97 milligrams of vitamin C. So one thing when I'm solving these kinds of problems is I like to give myself some indication of the difference. So 8 ounces to 97 milligrams. It doesn't matter. You could have said something like 8 OJs to 97 vitamin C's, or 8 cans to vitamin C. It doesn't matter as long as you're distinguishing the two. Then it says about how many is what we're solving for. And look at that, I was about to write it wrong, but I remembered it says about how many milligrams. So this is X milligrams. This is why I do it. It helps you to remember to not what goes with what. And then 12 ounces. So when we make proportions, if it's not clear, you need to have values matching up. Okay, so now we just cross multiply. And sometimes instead of circling everything, I just draw like a little x, and that's going to give me 8x equals 12 times 97. And now you're really seeing the utility of what I was talking about earlier about in terms of multiplication. I don't want to multiply 12 times 97. That's going to be really, really, really ugly to do. So I'm going to divide by 8 here instead. And now all I have to do is simplify 12 times 97 over 8. So I do know that both 12 and 8 are divisible by 4. So that would leave me with 2 and 3. So I'm left with x equals 3 times 97 over 2. Now, I know that 2 does not go into 97 because 97 is odd, and I know that 2 does not go into 3. As a little tidbit, actually, I knew that whatever the number was on the bottom was not actually going to go into 97 because 97 is actually a prime number, and so prime numbers are only divisible by themselves in 1, which is just a fancy way of saying the only thing that I can break 97 down to is 1 and 97. So 2 is not going to go into 97, so we're good. Okay. All right, so from here, there's not a lot more I can do other than multiplying this out. So now I'm just stuck to do old school multiplication. 7 times 3 is 21, carry the 2. 9 times 3 is 27, plus 2 is 29. So this is 291 over 2, which is x. And there's our answer. So there you have it. So I hope that this makes sense. Let me know what y'all think. If you need some more assistance, please reach out to me. Y'all know how to get to me. And I will see you in the next math video.